Hi, welcome to section 5.5C, factoring difference of cubes. This section is going to be very similar to the previous previous section, factoring sum of cubes. So we're going to go straight into the examples. Now, before that, here I give out a reference of perfect cube numbers, perfect cube variables, and perfect numbers with variables. These should be in your notes already. If not, I recommend that you make sure you have these. I will be using these as a reference. So first off, example 1, factor completely 343 x to the third minus z to the third. So one thing I haven't mentioned in the previous section was when it comes to factoring completely, you always want to check if there is a GCF before conduct any kind of factoring. So if you look between the first term, 343 x to the third, and the second term, z to the third, there's nothing in common, so there's no GCF. Next, since this is a two-term problem, you want to check what is the relationship between those two terms. So looking at it, there are two methods for two terms, which is factoring difference of squares and factoring sum or difference of cubes. So if I look at 343 x to the third, near them are a perfect square. So I can rule out that this is a difference of squares. Then I need to check if it's a difference of cubes. If I look at it, 343 is indeed a perfect cube. So if I go to my list of perfect cube numbers, the one in highlight in red, there is a 343. So it is a perfect cube. Then looking at my variable, x to the third, since it's up to the third power, that is a perfect cube. Looking at the other term, z to the third, also a perfect cube. So these two right here, this problem, are a difference of cubes. So we're going to be following the rule that is listed out on the right. So we're going to find the a and b value. So first, the first term, I'm going to say that this is going to be my a to the third value, which is the one I underlined in blue. And then this would be my b to the third value. All right, so for the first term, we have to figure out what multiply itself 3 times that will equal to 343 x to the third. Now, if we look at the number 343, we know that based on the list of numbers that I provided earlier, for 343, we need to look for the base, in this case, the 7. So 7 multiply itself 3 times, 7 times 7 times 7 will be 343. So for a, it will have that 7. And then for x, when it's x to the third, and you're trying to find the value of a, so when you do the cube root of x to the third root of x to the third, then it will simply be x. So my a value will be 7x. Now for the b value, we have to think what times itself 3 times that will equal to z to the third. So the only way a z to the third can happen when it multiplies itself 3 times is that b has to be z. The reason is because if you do z times z times z, you get z to the third. So my b value will be z. Now I'm going to fill in the values for a and b found in this structure. So my A value is 7x, followed by the minus, then my Z value, close parenthesis, and then open parenthesis. Now here, it says A squared. So I'm going to square my A value, which is 7x. All right, let's not forget that square. Then followed by that plus. Next is going to be my A value times the B value. So 7x times my B value, which is Z. Then followed by the plus. So what I'm going to put is my B value squared. So Z close that up and write the square. And then close it up again with the parenthesis. All right. So the first group, the first factor, there's nothing you can do about it. You're just going to leave it the same. So I'm going to write 7x minus Z. Now for 7x squared, that means that it's going to be 7x times 7x. When I write that out, when I multiply, we will have 49x to the second power. Then the next part, it will be 7x times z. So basically multiplying to another variable, you're just going to put it together. When you're multiplying two variables together, and you just put it in order. So it's going to be 7x z. Followed by that plus, and then next, it says z squared. So that means that we're going to do z times z, which will come out as z squared. And let me close that up. All right, we finished simplifying. So this will be my final answer for this example. So we have 7x minus z times 49x squared plus 7xz plus z squared. So this is pretty much what we would have to do when working with a problem that has a number with a variable as the first term, or any of the terms, and then the other term is just variable. All right, let's move on to example 2. So looking at this, 125, that is a perfect cube number. 729 and the s to the third, both of them are perfect cubes. So these two terms are perfect cubes. So we'll be factoring difference of cubes. So the first term, 125, that's going to be for the a to the third. And then the second term will be for b to the third. All right. Now we're trying to find what is the value of a when it multiplies itself 3 times, it equals to 125. So looking at the list of your perfect cube numbers, the only choice you have, or the only option you have, is that a has to be 5. Now moving on to our second term, what is the value of b when it multiplies itself 3 times to get you 729 s to the third? So the only option we have For the number for 729 is 9. And then for the variable s to the third, when you multiply itself 3 times, then it's going to be just s. So here we have, for our b value, 9s. When you multiply that itself 3 times, you will get 729 s to the third. All right, so let's start writing out our factors. First is 5, followed by the minus, and then followed by 9s. And then let me close that parenthesis. Open parenthesis for the second group. Now this one, it says a squared, so I want to square our a value, which is 5. Then followed by the plus. Next is our a value times our b value. So it's going to be 5 times our b, which is 9s. After that, followed by another plus. So it's going to be b squared. So my b value, which is 9s, we're going to square that. All right, I finished setting it up, filling in my a and b value. Now I'm just going to simplify in the second group, the second factor. So the first group, 5 minus 9s, will stay exactly the same. All right, so here it says 5 squared. That means that we're going to do 5 times 5, which will be 25. Then in the second part, a times b. So in this case, 5 times 9s will be 45s. Then plus. So here, it's going to be 9s squared. So that means it's going to be 9s times 9s, which will be 81s squared. Then let me close that up. And then this will be our final answer. So we have 5 minus 9s times 25 plus 45s plus 81s squared. All right, so we just finished factoring for 125 minus 729s to the third. So make sure that everything's all good. Make sure that you're familiar with your perfect cubes, perfect cube numbers, perfect cube variables, perfect cube numbers with variables, especially when you're going to be, if you might be working with 2 variables in both terms. So again, as I said before, and here I have as a reference, when you're trying to find the base value when it's a perfect cube 125a to the third, the base value is 5a. When you're trying to find the base value for 64n to the third, that would be 4n. And then I can say the same thing, 729u to the third, the base value will be 9u. That's going to be helpful when you're trying to find your a and b value.